Hello and welcome. Today we're having another lesson in organic chemistry where we're looking at enolate reactions. So what are enolates? Enolates are very good nucleophiles, and they contain an O- with a double bond. So it has an alkene part, so that's the ene part, and then it has the alkoxide part, so enolate. So for example, if you start with this carbonyl compound, in this case we have a ketone because we have an alkyl group on that side and another alkyl group on the other side, and then you have the carbonyl in the middle, so that's a ketone. And then you react that with a bulky or hindered base like LDA, and LDA is actually lithium with a positive charge, and then nitrogen, so it's lithium diethyl amide, so it has two ethyl groups, and it's a very good base. It will not act as a nucleophile, instead it will obstruct a proton, so the LDA will pull that proton, and then the bonding electrons will move here to form a double bond, and at the same time the double bond to the carbonyl will move to the oxygen, and that will give you so now you end up with a minus charge at that position, but here you're going to have a double bond, and that's actually an enolate intermediate. So enolates are very good nucleophiles, and they can react with various types of electrophiles. So for example, if you reacted with an alkyl halide, say alkyl fluoride, then the two electron pairs that make the minus charge will come back to form a double bond, and at the same time that alpha carbon, this one here, the electrons, the double bond electrons will flow through that to form a bond with a carbon that's bonded to the fluorine, and then at the same time the fluorine will leave. So it's an SN2 type reaction, and that will give you this product. And now we have the carbonyl back at that position, but now we formed a new bond here to the alpha position, and then it's bonded to this carbon here, and then you have those three carbons, and that will be the product. Alternatively, the enolate can add to another carbonyl. Say you have a ketone, let's say you have that there, and now that carbon will form a bond with the carbonyl, and then the electrons there will flow to that oxygen, and you end up with the carbonyl at that position. But now you have that new bond and this one here becomes O-, so that will be the intermediate, alkoxide type intermediate, and then that can be worked up by addition of a proton, H+, or you could even add water, so either an acid or water, and you end up protonating that. So you end up adding a hydrogen, and that becomes an alcohol. Now that reaction can stop there, but if you have heat, then you end up losing a proton at that position. So you lose that hydrogen, with the OH at the same time, so you get elimination of water, and that results in an alkene formation. Well, now we lost that hydrogen, and we also lost the OH. We also lost the OH, but instead we end up with an alkene at that position, and that is a stable product because you have an alpha-beta conjugated system. So we have that double bond in conjugation with the carbonyl. Next time we're going to look at a reaction. Instead of a ketone or aldehyde at that position, we're going to use either an ester or an acid halide. Thank you very much for your time. If you enjoyed this presentation, please like the video and also subscribe. And feel free to leave a comment. Bye.